Hi, friends. Okay, we are here for one more PowerPoint for today. This one was made by my good friend Eric Anderson. He is another guy from church that we know, that me and Jeremy know, and that is a good friend. I will say, like the standard population, Mr. Anderson turned his PowerPoint in exceptionally late, and it's longer than 10 slides, but that's okay. It's still pretty good, so I thought I would share. So here is Mr. Anderson's PowerPoint. It says, click here, or what happens when you click on a link. Technology appears to be Mr. Anderson's thing. Also, side note, due to the 17 slides, I won't be reading every single slide, but we'll go through it. Okay, here we go. Clicking a link, it's something we do dozens, hundreds, thousands of times per day, and it seems quite simple, right? They are not as they appear from the point which you click a link until a web page is displayed. Dozens, sometimes hundreds of computer systems are involved, and they all have to work reliably for that link to have its desired effect. Okay. First, some scope limiting context. To reduce the scope of this presentation from a mind-numbing thousands of slides to a more this is getting a bit bored, dozen or so, I need to limit the scope and make some assumptions. First, some scope limiting context. He's assuming that we're at home, you're using a laptop, or you're using a desktop, not a tablet, connected via a standard cable, and you receive an email from a friend, and you click on that link, which opens your Chrome browser. First, some scope limiting context. Encryption. When using the web, nearly all communications are very securely encrypted these days. This is great. Is it also complex to understand? I will wave my magic wand and act as if it just works. Many pieces of network equipment are involved in making sure your internet works properly. I will ignore the existence of the vast majority of these. As a side note, I won't say that. Okay. First, some scope limiting context. For the nerds in the audience, here are some other things I'm going to ignore. Okay. Those are tiny dots that I'm not going to read out loud. What's in a link? Sorry, you thought you were done with context settings. So did I. Tough. We need to learn what's in a link before moving on. For example, we will use this link. It's an Onion article with the title, Birthday Cards from Grandma Becoming More Religious. That's kind of funny. What's in the link? The link has 3 parts. HTTPS, local.theonion.com, which he says this is the host, and everything after the third / character starts with birthday in this example. It's kind of great. Finally, okay, click the link already. Okay. Who do I need to talk with? Your browser needs to figure out which servers to talk with. It does this using the domain name system. The DNS allows computers to take human-readable names like the host, local.onion.com, and look up which computer addresses, IP addresses, correspond with the host. To do this, your computer sends a DNS query to your Wi-Fi router, and your router responds with, let's look at this example. Okay. Who do I need to talk with? You can illustrate what happens here using this command program. That's a lovely command program. Here we see the Onion is serving requests for the host from our 4 different IP addresses. Since there are 4, your browser can select any one of them. Let's choose these 3. Okay. This IP address corresponds with a computer server managed by the Onion, which they serve to serve their website. How do I talk to that system? Without delving too deeply, your laptop needs to know how to talk with the server IP address. By default, computers only know how to talk with other systems directly in the same network. Skipping ahead, to talk with the systems outside your network, a router is required. This is a specialized computing device that knows how to exchange data between multiple networks. And it can help your computer. Phase 3, let's load the page. Okay, now that we know the 1 IP address of the server and 2 how to talk with that server, now we can actually ask it for the page. To do this, the browser uses HTTP as protocol, issuing a request to the server. This request is very much like a conversation between 2 people. It goes something like this. Phase 3, let's load the page. Browser, hello, are you the Onion? Server, yes, I am the Onion. Browser, okay, I believe you. Please send me Birthday Cards from Grandma Becoming More Religious. Server, okay, here you go. At this point, the server sends the page contents to your browser. Phase 4, display the page. The page contents sent to your browser by the server are a mix of HTML, CSS code, JavaScript and other items. Your browser knows how to interpret all of these things, and they lay them out as intended by the page designer. Congrats! You can now read a snarky article from America's finest news source. That's it. Simple, right? As mentioned earlier, this is a very simplified take on what happens when a web page is loaded. For some context on how simplified it was, I'll give you a few stats. The page actually takes 500 SUM requests to fully load. My computer in this set of 70 servers exchanged something around 4,000 packets of data to load the page. All this happened more or less transparently in under 2 seconds. That is impressive. And I would note here, we as educators and students know that there were some servers around the country that were really struggling today with all of the requests to look at. So this is kind of interesting. All right. I hope you enjoy this brief tour through the internets. The end. I like the end. So if you wanted to know about how some very basic internet stuff worked, I liked this one. Click here, or what happens when you click on a link. Excellent, Mr. Anderson. Pause.